My calculator. I'm unprepared this morning. I know the first thing I'm supposed to do in that bell ringer is distribute that 5.3, but I don't know what 5.3 times 5 is. Say it again. 21.5? 41.5. That feels really big. 26.5. Oh, okay, thank you. Equals, and then if I distribute that, I would have 3 plus something b. 10.5 minus 2.98. I see some like terms that I could combine on that right side. So I'm going to have 5.3b minus 26.5 equals 3 minus 2.8. Isn't that 0.02? Plus 10.5b. This one is another weird one. My goodness. What do you want to do next? That sounds good. Let's do that. Okay, I'm out of room. I'm going to have to go up to the top where I bet you wrote the learning targets. I'm so sorry. You know what? We have a quiz tomorrow and a notebook check on Friday, so you might as well just keep on writing underneath. Never mind. 5.3b. What is 26.5 minus 0.02? I don't know that. 26.48 equals 10.5b. Now what? I need something to do. Okay, that sounds good. So I would have negative 26.48 equals, I need to know 10.5 minus 5.3. 5.2. That's an ugly 5.2, but nonetheless it's a 5.2. Now what? Emmy, will you turn it on low cool? And what do I get for B? I know it's negative. I need to know 26.48 divided by 5.2. That makes sense, because 5 times 5 is 25. So we know it's a little bigger than that. So that sounds good. Sounds about right. I don't know why this has been happening all week, but the one on the right is, again, easier than the one on the left. I don't know. Please ask me. Because Lord knows I've done something wrong this morning. Shouldn't it have been a bigger number? Yes, I agree. I think that number's wrong. It's going to make the rest of it wrong. Yeah. So what Derek did was he added 0.02. Or he didn't do this minus this. You're right, Catherine. So this should be a 26.52, not a 48. 26.52. Okay, right? Okay, so then what would your last number be? 5.1. It's still negative. So we're just a little off. Well, that's good. I mean, we didn't make a major. Oh, thank you, Catherine. I knew there was something seemed fishy, but I hadn't had all my coffee this morning, so I was rolling with it. Sinuses, they're a pain. On that right-hand side, it's a lot easier. Let's combine those like terms first. And we would have 10w plus 6 equals 7w minus 21. I could subtract 7w from both sides. I would have 3w plus 6 equals negative 21. I could subtract 6 from both sides. I'll get 3w equals negative 27. So w equals negative 9. That one's so much easier. So much easier. I don't know why whoever made the bell ringers so late put the harder ones on the right. Strange. Okay, yesterday we did easy circle stuff, let's be honest. It was pretty easy. Name the circle, name a radius, name a chord. Given the radius, what is the diameter? Given the radius, what is the circumference? Here's the circumference, find the radius. It was just basic circle stuff. Nothing too complicated except for, you ever worksheet still? Yeah, that one. The only complicated one on the 10-1 in my mind is this one. But we worked an example like that yesterday. Otherwise, everything should be fine. 14 and 15 are also kind of complicated, but again, you aren't surprised that I've turned everything into a right triangle issue. This is a 45, 45, 90, so my gosh, you ought to be able to get the hypotenuse without using Pythagorean theorem. But worst comes to worst, you can use Pythagorean theorem. That one's a triple, but worst comes to worst, you can use Pythagorean theorem. You know me, I'm going to put triples, I'm going to put fun things. I like that. I like to see if you remember somebody out there. Okay, so today we're actually going to talk about other parts of a circle. So yesterday we were focusing on things on the inside, like the lines inside. For instance, in this picture I see 3 radiuses. I don't see a chord. I don't see a diameter. Today we're going to focus on the arcs themselves, so the outer side, the crust side of the pizza. We're going to talk about that. The first thing is a central angle. So a central, I don't know if I hole punched these wrong too. I was on a kick, let me tell you. A central angle of a circle is an angle whose vertex is in the center and whose sides are 2 radii of the circle. So in the center and its sides are the 2 radii, so this is an example of a central angle. And in fact, in that picture to the side, the tiny one, 1, 2, and 3 are all central angles. And when we add them all together, what should their sum be? Yeah, because it's a circle. So the magic number today is 360. Okay, so, oh goodness. For our first example, we're really just going to figure out what's missing from 360. Like 360 minus the numbers given. So, what is the value of x? $140. And how do you figure that out? You do 360. You subtract the 130. You'd have 230. So we did this one. And then this one's 90, so we've got to subtract 90 more, and you'd get 140. Okay, what is x in the second circle example? It is 50. Again, 360 minus 165, you'll get some number. I don't know what 360 minus 165 is. I would like to know that. 195. And then if you subtract 145 more, you get 50. So we're just subtracting the numbers given to find the missing central angle. But we're always subtracting it from 360. Okay, and then we have this last one. I need to know what x is. Someone other than Derek? 145. Again, if we were to add up the 360 minus 40, well, that would give us 320. So I found this one. If I took off 90, $320 minus 90, ma'am. I can't. Easy math is beyond me sometimes. 230. Why is that? I don't know. 230 minus 85 will give you 145. So we're just subtracting the angles given from 360. So that has to deal with the central angles. Now we're going to talk about the actual outside piece, the crust itself. So I think of it as the crust because I relate everything to food. The way I thought of the circumference is finding all the crust added up. But it's actually called an arc. That makes sense too. So an arc is a portion of the circle defined by two endpoints. A central angle separates an arc into two arcs whose measures are related to the measure of the central angle. Okay, so we've got two kinds, that's a lie. We've got three kinds of arcs. We've got this baby arc, so a smaller arc, and it's called a minor arc, so that's the small one. We have the bigger arc, and we call it a major arc, but in my mind, I always think of the bigger arc. To me, it looks like Miss Pac-Man, and especially does if you highlight the whole circle of that region. So this one looks like what Miss Pac-Man's eating, the minor does, whereas the major arc, if you color in everything with it, the whole circle with it, it looks like a Miss Pac-Man. And then of course, if you have, like, it's not minor, it's not major, it's somewhere in between, and it's exactly half the circle. We've already heard that vocab term before. It's called a semicircle. You had to know that vocab term when we did area of a circle. Okay, so again, you know I relate everything to pizza or some sort of food. So if those terms don't help, maybe this will. A minor arc is when we're talking less than 4 slices of pizza. Major arc is when we're talking, it's got to be greater than 4 slices of pizza. You know, I'm thinking a normal pizza that's cut up into 8 slices, by the way. If you're doing something super fancy with your pizza, you're out of my league. And then if Kevin eats exactly 4 slices of pizza, he's eating a semicircle. So is it a little pizza, a lot of pizza, or half the pizza? That's how I think of my arcs. Okay, so if we know one of the numbers, like if we know this central angle is 50 degrees, then that means that arc is 50 degrees. But if this central angle is 50 degrees, what's remaining? Well, that would be 360 minus 50, which is 310, so that the major arc would be 310 degrees. And then a semicircle, since it's exactly half a circle, it's going to be 180 degrees. That makes common sense. Okay, so our next example says GJ is a diameter, circle K. Identify each as a major arc, minor arc, or semicircle. Find its measure. I know there's one like this on the exam. Okay, so they asked for the measure of arc GH. What number should I put for the measure of arc GH? It is, because it matches that central angle. And then they ask for the measure of arc GLH. So I got to go in careful order. They said GLH. So what number should I tell them? Also, that was a minor. It is. Okay. So how did she figure that out? She did 360 minus our tiny arc, minus the blue arc. And she got that major pink arc, which is 238. Now, if she was being complicated, which she wasn't, but if she was being complicated, she could have done 180 minus 122, gotten 58, realized that was a semicircle, which is 180. 180 plus 58 is also 238. Her way is much easier, but if you're a complicated person, you can make it complicated. Okay, are there any questions on example 2? I like the arcs. They seem pretty easy. PM is the diameter of circle R. Identify each arc as a major arc, minor arc, or semicircle. Find its measure. Okay, so MQ, is it major, minor, semicircle? It's minor. And then it wants me to find its measure. What number should I put? Why would I put 65? Okay, perfect. So you realize this is a semicircle. We've got half a circle from here to here. So it's got to add up to 180. 180 minus 115 is 65. That is an easy way to do that. Good. Okay, the next problem wants to know the measure of arc MNP. Well, first, is that a major arc, a minor arc, or a semicircle? So if you really want to get on my nerves, I mean super on my nerves, what number would you not put? If it's a semicircle, what number should you put automatically? 180. So people who get on my nerves write the word semicircle and then don't have the number 180. And then last but not least, it asks for MNQ, and I have to go in careful letter order. So M, N, all the way over to Q. I did it with a black squiggle. Is M and Q a major arc, a minor arc, or a semicircle? It's major. And what is its measure? Okay, and you do 360 minus 65, and that's where you got the 295. Because it was everything but that piece. So 360 minus that piece is 295. Okay, so there's nothing earth-shattering with that. Flip to the back and we'll finally get to how it's useful. Oh. What word should I put in that first little slot? It starts with a C. Read the whole sentence. And you'll know what word to put. Although that is, yeah. That is a good C word, but no, he's correct. It's congruent. So congruent arcs are either in the same circle or they're in congruent circles. And they have the same measure. Congruent means the same thing it always has all year long. Now, the reason circles are useful, and the only reason why I hate that we saved them till the end, is that there's potential that probably on the ACT there'll be some sort of a pie chart that you need to read. And you need to give it some information. So they want us to find the measure of arc CD, which is from here to here. Thank you, dear. But they didn't give us any numbers this time. They only gave us percentages. They told us arc CD is 18%, but surely that's not my final answer because that's not a number. It's not just going to be 18 degrees because if we add up all those, they don't add to 360. So we actually need to take the decimal value, so 0.18, and multiply that times 360, and then we'll have a number to put on it. So what number is that? So, okay, so it's actually 64.8. Okay, and then the next one is for BC, but BC is also 18%. So I don't have to do any math. What number should I put? 64.8, because those are congruent arcs. And then the next one, it says the measure of arc EF. Let's see. EF is here, and it's 14%. So I'm going to do 0.14 times 360. And my number is going to be something. 50.4. And I know she's right because it went down, which is good because 14% is less than 18%. And then they asked me to find the measure of arc FA. And I already know what number to put. Exactly, because it's another 14%. So it's also going to be 50.4. Are there any questions about that? That I've seen. They normally don't make it that easy. They would probably make you add like track and volleyball, or volleyball and softball. They'll make you add a couple pieces first. But besides that, it's that kind of a problem. Okay, and then blank arcs have exactly 1 point in common. So if I highlight this arc, CD, and I highlight this arc, BC, what would you tell me about them? What's a vocab term we learned in geometry that would describe those two arcs that are beside each other? Adjacent. So adjacent arcs have exactly 1 point in common. They ask us to find the measure of AED, and I'm running out of colors. AED. I've colored it purple. What number should I put for AED? Yes, because you do the 63 plus the 90, and you get the 153. Okay, they asked me to find the measure of arc. Yeah, I already colored it yellow. Pink. Yellow, good grief. Miscomment. CE. I need to know a number for CE. I'm stuck. 17. How did you did it already? I'm so proud of you. We'll come back to it though, but yes. Okay, and then they ask for, we're going to have to come back to that one because besides Ayana, I'm at a loss. Let's do, I'm adding low on colors. I need more colors. Let's do the easiest one up there. Let's do D. It says AEC. What is arc AEC? It's a semicircle, so what number should I put? Okay. So that one's the easiest one up there. Then let's back up to B. They want us to do ADB. So is that the A? Yeah. A to D to B. Man, that's going back into that unknown region. Goodness gracious. So let's think this through. We're confused on B and C. Let's make sure can we plug in some more numbers. So we know there's a 63 here. We know there's a 90 here. What number can I put inside this arc? What is 180 minus 63? Okay, so I know there's a 117 here. And then I have something interesting to show you. I'll use my yellow again. What is arc ABC? So what number can I put right there? I can put another 63. So then what's that missing tiny piece then? She's correct, because we know, let's think this through, we know it adds up to 360, so you could do 360 minus all the numbers to get that missing tiny piece. Or, I see a semicircle. I cover that up better. I see a semicircle. I know that this part is 90. The other part has to add to 90. 63 plus 27 is 90. Okay, so now I can probably answer all the rest of the questions. So they asked for CE, so I need to do 27 plus 90, and I would get 117. So she was correct. She was just a genius before she knew it. And then they asked for ADB. Well, you can add 63 plus 90 plus 27 plus 63. That's nice. There's an easier way. I would probably do 360 minus 117, and you'll get to the answer faster. But again, if you actually want to add up all the little tiny bits, you sure could. So most of it's pretty easy. Are there any questions about that one? That one was complicated. My hint to you would be that there are semicircles hidden everywhere in life. And another reason why we knew those two matched is because vertical angles have always been congruent. Okay, we've got one thing left, and then you can work on your worksheet. The good news is I will give you this formula in life. The bad news is you probably should learn it at some point, but I get less hard. L meaning the arc length. So arc length is the distance between two endpoints of arc measured in linear units, and arc length with L, radius R, and central angle measured x can be found by. So the x is for the central angle, and the L is for the arc length. So my formula is L equals x over 360 times 2 pi r. What number should I plug in for x? What number should I plug in for r? X is 75. What number should I plug in for r? 4. So it's just a straight plug-in chug. You type that in your calculator and you get... Yeah, I don't even know what I'm doing. I didn't even look to see if it was on the screen. Riley, I got lazy there for a second. I need a number. It's supposed to be a small number. It is. Okay, so what we did for the first couple problems where we were finding the measure of the arc length, that's different than finding the actual length of the crust. Crust is going to be a tiny small number. Arc, different thing. Crust, tiny small number. I'm going to skip this one because it's the same sort of thing. Straight plug and chug. Let's do the last one because it's the only one that looks a little bit complicated. Still same formula. So x over 360 times 2 pi r. They ask us to find zy. So I know to do 130 over 360. You're on my nerves. But what number do I plug in for the R? Perfect. If you type it in your calculator, you should get 11.34. Okay, so that's really all there is to say about arcs and arc length. I think they're just as easy as circumference and stuff, so it should be a nice quiz grade, I would pray. I talked